To really understand the atom in its core of the understanding, one has to understand also how charges interact. And this will be a very brief review of something that you may have seen in physics if you have taken physics. If you have not taken physics, this may look new to you. However, nevertheless, I think it's good to at least see it once, and hopefully we'll keep going back to this kind of interaction. We have to think, even though it's a simplification, that if our nucleus is positive and our electrons are negative, think of this as if it were like the solar system. It's not exactly the same. Actually, atomic particles behave according to quantum mechanics, and it's a little bit more intricate than that. But for the first approach, it may be good to understand that according to the Coulomb's law, and this is the energetic form of the Coulomb's law, positive and negative charges attract each other. According to the 1 over r, so the 1 over r potential, in which I try to plot here. What is this equation telling us? This equation is telling us a few things that I try to point out in here. The important points that one must remember so that we can understand the interactions in the atom. The first point is that charges will evolve towards a minimum of energy. This means that a negative charge will try to get as close as possible to a positive charge. This is why this is the kind of interaction. Unless there's something stopping this charge, the negative charge will collide with the positive charge. We will learn that there's some quantum levels that does not allow, so it will stop somewhere, but it's important to keep in mind that the electrons will try, because they are attracted by the opposite charge of the nucleus, they will try to get as close as possible. Okay, so if you have an electron up here, it will come down to as close as possible. Another important issue is that the higher the charge difference, the stronger the attraction. So this means that if the nucleus instead of 1 plus is 2 plus, like the nucleus of helium, this interaction becomes stronger. So this means that probably your electron will get a little closer because we have increased the charge in the nucleus. Okay, and finally, this last point to remember is that the closer charges of opposite sign, the stronger the interaction. So these two are somewhat related. This means that the attraction among this negative charge and this positive charge is larger than the attraction between this negative charge and this positive charge and this negative charge. The farther away your particle is, the smaller the attraction is. Okay, so what does that have to do with chemistry? Let me give you just a couple of examples with a couple of questions. In this case, I'm asking, what will be more strongly attracted? One electron in a carbon atom in the 1s orbital or in the 2s orbital? In this case, we have to remember that the carbon atom has a 6 plus nucleus, and the 1s orbital may be here and the 2s orbital may be here. We just said that the closer the charges of opposite sign, the stronger the interaction. So this electron, the one in the 1s, will be more strongly attracted than the 2s because it's closer. Therefore, it will be harder to remove. I'm thinking, for example, if against X-ray or any other kind of dangerous electromagnetic radiation. Okay. The other kind of question is, what will be more strongly attracted? One electron in the 2s of carbon or one electron in the 2s of nitrogen? The nucleus of carbon is 6 plus, the nucleus of nitrogen is 7 plus. In both cases, the electron is at the same orbital, so we will say that it's the same distance. However, looking at point 2 here, that says that the higher the charge difference, the stronger the attraction. This electron will feel more strongly attracted because the charge difference is larger. Okay, we will go back to these principles I do not expect you to understand these topics at the same level as if when you take a physics course, but it's important when we talk about energy of electrons and radius and ionization energies that we will be talking about in the following weeks.